So let me summarize the whole situation for you. From the period of about 1900 to say maybe 1930, physicists were terribly puzzled about the behavior of matter in the quantum realm. The familiar world of the continuous electric fields and continuous distributions of matter seemed not to apply. Instead, the world was discrete, with electrons surrounding atoms in fixed orbits. Probably even harder to accept is the idea that photons and electrons and the other denizens of the microcosm acted both like particles and waves. Even if you've heard this all before, if this doesn't confuse you, well, then you haven't been listening very well. It still confuses me, and it's not just you or me. The whole wave-particle thing has perplexed nearly a century of very smart people. However, whether we're perplexed or not, over that same century, people have been doing experiment after experiment, trying to find out where these ideas start to break down, and there's not a single measurement that does anything other than agree with these theories. Like it or not, quantum mechanics is here to stay.
Lecture 4. Einstein unifies space, time, and light.
The world of the ultra-small is but one realm that is unfamiliar to us, in part because of how the quantum nature of matter differs from our familiar and continuous world. That's not so shocking. After all, we see similar things like how the social interactions between two people differ greatly than an individual's interactions with a crowd. However, there's an even stranger aspect of the universe to learn. In a very perplexing way, the way we experience the universe seems to depend on how fast we go. Even weirder, people moving at different speeds will experience the universe differently. In our last lecture, we made a foray into the unfamiliar domain of the atomic and smaller, and that led us to some very surprising results. Waves and particles, which were once thought to be mutually exclusive, turned out to be inextricably linked in the world of the ultra-small. Even today, many people have trouble accepting the theory of quantum mechanics, but that's not the only theory that was developed in the early years of the 20th century that told a very non-intuitive tale. The ideas we're about to explore might even seem weirder. For starters, they will tell you that everything your everyday